Hello and welcome back to the second half of our discussion on linear inequalities. We're going to conclude this section with one final example. This is to solve and graph. Remember, for this example, we're using both properties of inequalities. That means the addition property and the multiplication property. If you'd like a refresher, please look back at the video that was just concluded. Alrighty, now for this one we have a more complicated looking inequality, but I believe we can use some principles we learned earlier and that we had learned from the past video to get through this, and I think we're going to do really well with this. Okay, let's take a look. It says we need to solve and graph. That means we need to solve for the variable and then use a number line to graph all the possible x values. Okay, so let's just start. Okay, we have 2 times the quantity, x minus 3, and then outside of that would be minus 5. It's less than or equal to 3 times the quantity, x plus 2, and then outside of the set we have minus 18. So let's just start by looking. It looks like we have some distributive property right here on this left side. Why don't we just look at this left side of the inequality and then we'll look at the right. I think that'd be a very good way to look at this. So if we start, it looks like distributive. Let's distribute that 2 across everything inside the parentheses. So it looks like we have 2 times x to distribute. Remember, that's a positive 2 times a negative 3, and that's a minus 5. So let's just simplify and see what else we have. So we have 2x, 2 times negative 3 is negative 6, minus 5. So just keep simplifying. We have 2x minus 11. And then looking on the right side now of the inequality, let's just continue on. So it looks like we have another distributive property. So we need to distribute that 3 across everything inside that parentheses. So let's do it. Let's have 3 times x plus that positive 3 that we were distributing times 2 minus 18. Okay, now let's just go through and simplify like we did before. So we have 3x plus 6 minus 18. Okay, so I believe we're going to just have 3x, okay, and then 16 minus 18. We're going to have a minus in there because 18 is larger, okay, and then I believe that 6 minus 18 will give us a negative 12. Okay, so let's just go through and get all the variables on the left side and all the regular numbers like 11 and this 12 over here on the right side. So we have all the x's on one side and all the regular numbers on the other. So let's start by subtracting 3x on both sides. We're subtracting because that's a positive 3x, and we have to do the opposite to get on the other side, which would make it a minus. So 2x minus 3x, that's just a negative x left right there. Minus 11 is less than or equal to, let's just drop that negative 12 on down. Okay, we need to get that negative 11 on the other side, so let's just add 11 on both sides. Have a negative x is less than or equal to negative 12 plus 11. We're going to have a negative 1 right there. Well, remember we're solving for x, not negative x, so we have to divide. Remember there's a 1 right there? We need to divide by negative 1 on both sides. There's a 1 out in front of every variable if there's not a number already there. So we do that division, we have that x, and what happens when we divide by negative? It just means the inequality flips the direction it's pointing in. So remember, it went from a less than or equal to now a greater than or equal to. What's a negative 1 divided by negative 1? Well, that's just positive 1. So x is greater than or equal to 1. Let's look at graphing it now. Remember, I like to put right in the center the number we're working with, and that's what x is equivalent to. That's that 1. Put some values on either side, so that's a 2 and 3 on the other side with a 0 and -1 on the other. Since this is an equal to, right there, that bottom that tells us so, we put a solid circle and for 1, and we're looking for values greater than 1. So it's going to be the values to the right of 1. We want to do some nice shading, and that is how to graph and solve a more complicated version of this inequality.